All right, folks, it's Bass Action, back in action here. In this video, we are going to go over the various types of transformations that you can do to a function. In class, we will go over how to combine those transformations into a single problem. So right now, we're just going to look at these various parent functions we have, and then you'll notice that down here below each graph, I have a particular transformation that we are going to perform on the given graph. These other values should already be filled in for you. We did those together in class, the names and the various intervals and the extrema for that particular graph. So let's just jump in to this letter B. You'll notice I didn't give any type of a transformation on the constant function because that one really isn't particularly necessary. So looking here at our cubic function, we're going to use that one to demonstrate this particular transformation. And what I would like to call your attention to on this is that the transformation we know is going to be a horizontal transformation here. We know this one's going to be horizontal because the value is being added or subtracted directly to the x value. So this is going to be a horizontal shift. So when we add or subtract directly to the x value, it is going to create a horizontal shift. Now, when I look at this addition or subtraction, what I'm going to mentally do is think what value would make this tiny little portion equal to 0. And since that value is a -3, our shift is going to be left 3. So when we look at our graph, we're not going to do anything to the y values. We're simply going to move all of the x values left 3. So if I just I'll start here down the bottom. I'm going to take this value and I'm going to move it back 3. And 1, 2, 3. Sometimes these are hard for me to count on these tiny grids. And then I'm going to take this one and I'm going to move it back 3. We're not doing anything to the y values. Then I'm going to move it back 3 and back 3 and then back 3 again. So we can move all those points back 3 and then we can just simply redraw the curve. And that would be our horizontal shift that would be left 3. And again, we know that because it's a -3 that is going to make this particular little portion equal to 0. Now on the next one, we are going to look at this negative in front, and this is going to create a reflection. In particular, this is going to create an x-axis reflection. So what we're going to do is we're going to take all of our y values and we're going to keep the x's the same. And we're just going to flip those to negative values. We've seen this x-axis reflection when we did our symmetry exercises earlier. So I can take these values and of course this one's going to stay the same. I'm going to move this down here to a -4. My other one I'm going to move down to a -9. Again, these are usually pretty hard for me to read. And a -9 and a -4. So if we take each of our points and we reflect them down, just changing the y coordinates to whatever the opposite sign would be, and that would allow us to create this x-axis reflection. On the next one, we are going to look at a y-axis, a vertical, and this will be our dilation. Now, the y-axis ones are going to be the easiest because all we need to do is take every y coordinate and multiply it by this 4. So when I come in here, and it's kind of hard to look at, we've got this 1/2, and when I multiply 1/2 by 4, that's going to get me, or I should say -1/2, multiply it by 4, that's going to get me a -2. A -1 times 4 is going to get me to a -4, and a -2 times 4 is going to get me to a -8. I've got to keep this tiny little 5, 6, 7, 8. Again, these are really hard for me to see. And then we can sketch in this portion. We're going to keep it approaching the asymptote as best we can, and then we can repeat that on the other piece. So we're going to go up to an 8, then I'm going to go up to a 4, and I'm going to go up to a 2. I Again, just taking those values and multiplying those y coordinates by 4. Okay, so that's going to take care of our first 3 transformations. Then we're going to do a couple more here. Again, I'm not doing anything with this identity function as a transformation because it also doesn't have any particular value. So now we're going to take a look at this next transformation. And what we're going to do is we're going to notice that this plus 3 is outside of the x. So that means that this one is going to be a vertical shift. It's important that you be able to recognize these just by looking at the equation. So now we're just going to take the entire graph and we're going to move it up 3. Again, all the y transformations are the easiest because you don't have to really do much thinking. They look like exactly what we want them to do. So we're just going to add 3 to all of our y values. I'm going to start here on this far left side. So I'm going to add 3 and it's going to move that up. I'm going to add 3, 1, 2, 3. I'm going to add 3. I'm going to add 3. And then I'm going to move all the way over and add 3. And again, I can draw in this nice curve. And it will eventually cross that x-axis, but for right now, we're just going to take everything and shift it up. On our next one, now we're back to an x value type of reflection. And again, we've seen this with our symmetries, that negative on the inside, a negative directly on the x value, is going to create a y-axis, it kind of feels backwards, reflection. So now all of our x values are going to flip over. Okay, so it's right here on our x, so it says take all the x's and we're going to flip their signs and it's going to reflect it over the y-axis. So the 0 will stay the same, the positive 1 will become a negative 1. The positive, when I take a look at this, my positive 4 will become a negative 4. And my positive 3, sorry, a little bit hard for me to see here. This positive looks like almost 10 there is going to reflect all the way across as well. Should be that point's not quite in the right spot, but that's okay. That's going to reflect over to here, and that's going to make our whole graph point the opposite direction. Okay, then our last one that we're going to do, and I'm going to tell you to put a big old star on this one because this is definitely our trickiest one that we're going to experience. This is a horizontal dilation, and these are always going to work in our minds backwards. Dilation. Okay, these ones are going to essentially work backwards. The way I like to always think about these is this 1/3, the x is kind of like a speed. So we're thinking, how fast is the graph going along our domain? So if we think of this almost like a speed, this 1/3 says that it's moving at 1/3 speed, which means it's going to take 3 times as long as it appears to finish. So what we're going to do is we're going to actually, you can either think of it as multiplying the x values by 3. So we're either going to multiply by 3. Again, this one's the trickiest. Multiply by 3, or we're thinking divide by 1/3. Mathematically, those are the same, but depending on how you want to think about it, that's going to make a difference how you process it. So I like to think multiply by 3. So I'm going to take all of my x values and I'm going to multiply each of those by 3. So my negative 1 times 3 is going to become a negative 3. And my negative 2 times 3 is going to become a negative 6. And my negative 3 times 3 is going to become a negative 9. Do the same thing on the other side. 1 times 3 is going to become 3, 2 times 3 is going to become my 6, and 3 times 3 is going to become my 9. So this becomes a very wide looking absolute value. But all the y values are going to stay the same. So now that looks extremely wide. Okay, so what I want you to do is spend some time looking at these different types of transformations and thinking to yourself how you would remember and keep them straight so that you can recognize them later.